Good morning to all the participants present here. So myself Zaiba, Assistant Professor from Nagarjuna College of Engineering. So today we are in the day 3 of the STTP phase sponsored by AICT. So today's speaker would be Nagarajan G sir. So he's from VI Solutions Bangalore. So before I start with he starts with the session, let me just introduce about him. So Nagarajan sir has postgraduated as power electronics engineer from Anna University, Chennai, and currently he's designated as a senior application engineer in VI Solutions Bangalore. And his key interest areas are measurement and automation, sensors, data acquisition, signal conditioning, then FPGA based system design, and power electronics. So we welcome you, sir. Thank you for coming to this session in spite of your busy schedule.
Thank you, ma'am.
Over
Thanks
to
for
you,
the
sir.
introduction. Yeah, thank you. So, very good morning to everyone. Thanks for the introduction. So, I welcome you all for this AACT sponsored FDP program. Which will be on applications of NI LabVIEW. So, and I hope everyone are safe during this pandemic situation. Hopefully, so you people have attended the previous sessions. Just a moment. My Yes, so I think it's fine. If my audio is not if my voice is not audible, if in some time if my screen is not shared or if it is not visible to you, you people can kindly drop your message in in your chat box. Fine. So today's session is going to be about how we can implement IoT, that is we used to call as industrial internet of things in LabVIEW, how we can develop IoT based applications in LabVIEW. So that's what the session will be about for the today's session. So let me just share my screen. We'll move into the content. I think my voice is audible. Yes. Okay, so if you have any queries, you can just drop your message in chat box. Okay, so I'll just try to share my screen. And
Yeah, your voice is
yeah,
audible.
thank you, sir. Thank you so much. I'll just share my screen right now. So I think, yeah, I think I now I can present. Yes, I have shared my screen. Let me know if the screen is visible to everyone. Yeah, thank you
Yes,
so
sir, it's
much.
visible.
Yes, so I welcome you all for this session. It's about introduction to an IoT using NI platform. So initially, basically, this session will be mostly it will be a hands-on session. So you people have already attended previous sessions, which was handled by our PS solutions experts. So it's this entire FDP is about applications using NI LabVIEW. So you know about the basic environment about LabVIEW, where LabVIEW is used, how you can create some VIs using LabVIEW, and I hope you people have seen some introduction about some hardwares also. So today I'll be explaining about how we can develop an IoT based system using NI LabVIEW. Fine. So initially, so from where usually we used to call as industrial internet of things, so which has come from a term called internet of things actually. So first, from where this internet of things has been evolved. Okay, so initially if you see, this internet of things has been evolved from internet of people. Okay, a simple example, previously if you see in the olden days and all, so if you want to share any information, okay, if you want to share any information, so we used to do that postal mailing and other services and all. And once internet comes into picture, okay, once internet comes into picture, if you want to share a document, okay, if you want to share a document, So instead of sending it through a courier or a parcel service, what you can do is, if you have a scanner, if you have a scanner with you, you can just scan the document and you can just attach to the mail and you can send. So you're going to share the information from one people to another people using internet as a medium. Fine. So that's what we call as actually internet of people, where the humans from one place to another place can interact among each other by using internet as a medium. A simple example you can take: now we are in lockdown, so everybody are doing work from home. How people are so people will be at different places. Okay, so how they are connecting together by using internet as a medium. Okay, that's a simple example for internet of people. So now today we are handling some sessions which is completely through online. How it is happening? By using internet of medium, where we people, we are at a different places where we are connecting together by using internet as a medium. So that's what we say, internet of peoples. Okay, next thing is internet of things. Okay, so when you see things, okay, so things is a non-living thing. Okay, so it is a product. Okay, so which is not a, which comes under non-living category, so we called as actually things. Okay, so internet of things. Fine. So when things can start to communicate between each other. Okay, so when things one for example, if I have a motor, okay, if I have a motor, and if I have a switch. Okay, so where remotely, okay, where I can turn on and turn on and turn off the motor by using a mobile phone, which means that my mobile phone and the motor is going to talk to each other by using internet as a medium. Okay, so when things starts to communicate between each other using an internet as a medium, so then we called as actually internet of things. Okay, so this is how internet of things has come from internet of people. Okay, so if you see, I have a small video, so which will tell about how IoT is used in our day-to-day life. Okay, you can just watch the video.
It's crazy that we doubled our use of energy in the last 50 years. We can't keep this up. 1,400 transport units, 520,000 kilometers per day, 1,750 hours of travel. What do I need? Milk, eggs, vegan meat, vegetables, chewing gum. Yes, hello. No, I still need to order bandages. Oh, there aren't any more needles. Where's the... I'll put you through. Oh, and I still need to do this. Don't you have the feeling we're standing still all the time? Why has it become part of our lives? Isn't it strange that days are getting longer? Shouldn't evolution make the world more efficient? And while we're standing still, even more. Why can't we focus on people instead of procedures? What if objects start to sense and communicate, becoming tools to help us deal with complex and urgent situations? What if all objects were interconnected? What if there was an Internet of Things? With the Internet of Things, applications are infinite. We could be able to monitor our transport better, winning precious time at any turn. We'd be on smart logistics as we know it. With an Internet of Things, we could be able to monitor from a distance. Instead of spending time in a hospital, people could actually live their life. Emptying our carts would be a thing of the past. It would also limit forgetfulness. We wouldn't even need a shopping list. We could easily ping our refrigerator at home to tell us what's missing. If we want to be smart about energy, we could let energy be smart about itself. With the Internet of Things, we could be able to manage our world differently, adding a new dimension to the Internet as we know it. The Internet of Things, part of our future.
Okay, I hope you people have just watched a video which just gives a small information about what is IoT. So in the video, if you have seen, so how the things happen before IoT comes into picture, and how when IoT comes into picture, and now when it comes into all applications, how things has been changed. Okay, fine. Simple example, if you see, there is something in the video they have shown about a patient conditioning monitoring system. So if the patient has any problem, and if he wants to if they want to check any of the parameters, so usually we used to visit the hospital, and then so we'll consult with the doc. We need to get an appointment, we need to consult with the doctor, so you have to make all the checkups, and then you need to get ready. Okay, so you'll get all the information. So if you see, once Internet of Things comes into picture, so when they have sensors, okay, so when they have, I hope you people know about sensors. So sensor is nothing but a system which is going to measure the physical parameter. Okay, so if we have a sensor, okay, so think that I have an ECG sensor, which is a pulse sensor, which is a smart sensor. Okay, so the difference between a normal sensor and a smart sensor is where smart sensors have an option, has a capability to share the data, okay, with the other systems using internet as a medium. So when we have an sensors, okay, smart sensors with us which can measure our biological features, when it has a capability to transfer the data. Okay, so instead of visiting a doctor to the hospital and measuring all the parameters, right? So when we have an IoT based systems where the doctors can monitor the patient's condition, they can collect all the data of the patients, so through internet as a medium, and once the people arrive, they can just talk with them, and they can consult like what are the major issues or how the health condition of a patient would be, and they can get the easy solutions. And if you see one more, nowadays I hope you know about autonomous vehicle, right? So autonomous vehicles, so where the cars, so we know about the driverless car systems and all. Okay, so how it is happening? So without any human, the car automatically drives by itself. How it is happening? So the car will consist of a more number of sensors, so which is used to measure the different parameters, and that will be given to the system. So depends upon the data which is getting from the smart sensors. So it's going to take a decision. Okay, it's going to take a decision, and then it is going to take some. It is going to give some actions over there. Fine. So simple example, when the car moves in the road. Okay, so if we have a sensor, so there will be a lot of sensors to measure the distance between each and every vehicle which is coming near to the car, so that it can take some action to reduce the speed or to increase the speed. So how it is happening, where one car, okay, so car is nothing but a non-living thing which can talk. So one car which can talk to the multiple cars on the road, right? So how it is happening? It is all because of internet. Okay, internet of things, where they are sharing the data among each other without any human interface, by using internet as a medium. Okay, so these are the small examples where IoT systems were developed. Okay, so usually we used to call two things. One is called as commercial IoT, and another one is called as industrial internet of things. Okay, so when you see commercial IoT, a simple example is home automation system. And you know, like now, when a fridge has an so when the fridge and our system are connected with the internet of things, right? Even from, so we can know what are the products available in the refrigerator. So if the products are not available, automatically the refrigerator will send a message that, okay, for example, if the milk or curd is not available in the refrigerator, it automatically it can send a message that, so the milk as well as the curd which is not available in the refrigerator, so that we can communicate with the fridge through internet. It can send a message to a mobile using internet as a medium, so that we can do some action. See, without communicating, the things are communicating with the other things. So by using internet of as a medium, right? So that's what we say, when things has an option to sense, okay, and it has an option to communicate, so then we can achieve internet of things. So that's what things plus sense and communication. Okay, so simple example, human. Okay, so where we have brain, so we have we have an option to sense, okay, like taste, smell, sight, and all those things, where the brain can take some action. So when you see machines, okay, the machines, the which is going to be the brain or processor is going to be act like a brain. Okay, so where the sensors are going to measure the different parameters. Okay, so as we are the engineers, so we'll develop the code, okay, in order to measure the parameters from the sensor. Once we measure the parameter from the sensor, so we are going to develop a code. So what action to be taken once we get the data, whether we are going to give some command, or we are going to share the data from one point to another point, or we are going to export the data or import the data. all those decisions will be taken by the engineers. We are going to do the program, and then we'll dump the code and we'll dump the code in the system, and it'll automatically start to work as a standalone system over there. Okay, so in the same way, simple example is, you can see, we have a smartphone. Okay, we have a smartphone. So where when if you see the mobile itself, right, usually we'll have a basic mobile phone where we have an option to call, and then we have an option to send the messages. Okay, so later part, when internet comes into picture, when the mobile phone has the option to connect with the internet, so we then automatically we used to call it as smartphones. Okay, so why it called a smartphone? So where this smartphone can be connected, the phone can be connected with internet, and we can share the data, we can receive the data, all those things by using internet as a medium. Fine. So this is how the things can sense and it can take some decisions over there. Okay, if you see an individual IoT device, okay, so when we say IoT device, it has some major components. Okay, it has a major components. If you see, the first one is nothing but your sensors. Okay, so the sensors are which are the which is going to plays a major part in IoT systems. So where we can get the informations. Okay, for example, think that I'm going to automate a home. Okay, think that I'm going to automate a home. So when I make a home automation system, so when the human enters, so automatically it has to sense the human motion. Okay, so and I want to turn on and turn off the fan, depends upon the human motion available inside the movement inside the home. Okay, or if I have a temperature sensor where I can measure the ambient temperature of my room, depends upon the temperature, automatically I can make my air conditioner to turn on and turn off with respect to some conditions here. Okay, so when I want to do all those parameters, when I want to do such kind of activities, I need some sensors. Okay, I need to have sensor to measure each and every individual parameters. Okay, and once I measure all the parameters, so that should be given to a control unit. Okay, the control unit it may be embedded based system or an FPGA based system, or it could be a microcontroller based system itself. All the informations will be given to the control unit. Okay, so when you say a control unit, it's going to be an electronic device. Okay, so automatically when we have an electronic device, so when the device has to work, right, so it needs a power supply. Okay, it needs a power supply, then only the system can work. Okay, and so for that you can make use of battery. Fine. Next one is going to be the communication medium, where your hardware or your system, okay, it should have a capability to communicate with the other systems using internet as a medium here. Okay, so that's what, so all these together will form an individual IoT devices. Fine. Next one, if you see network of IoT devices. Okay, network of IoT devices. When we have more number of IoT devices which has a capability to share the data, or it can receive the data using internet as a medium. Okay, so when all these devices connected to the internet, so we call it as actually network of IoT devices, where one device can transfer and receive data from one point to another, where it can share the data from one IoT device to another IoT device without any human interaction by using internet of medium, so which completely forms a network of devices here. Fine. So if you see here, so that's what we call as actually internet of things. Okay, fine. When you can see in the slide itself, I have some sensors. Okay, so where I have some sensing devices which is used to measure. See, if you see here, I have a temperature sensor which can measure the temperature. Okay, a moisture sensor or a humidity sensor, and a light sensor where I can measure the intensity of light, so which is going to receive, okay, which is going to sense, and it is going to give the information to the system. Okay, so to the systems, and then it's going to take some actions here. Okay, so a simple example here, a smart house system where we can control the different equipments or devices in the home when it has a capability to connect with internet. Okay, so it forms a smart house system. So for example, so when I have when I make a system as home automated system where I can measure all the parameters. Okay, so using my mobile phone, so which means my mobile phone and the other devices present in the home, which all connected to an internet. Okay, so where we can share the data here. Okay, so this is a small example of IoT. Okay, so internet of things here. Fine. So if you see here, we have an application layer, we have a device management platform, connectivity, and then we have a devices here. Fine. So as I said, right, we call industrial internet of things and we call commercial internet of things. Okay. So when you see industrial internet of things, okay, industrial internet of things, right? So when in industries, okay, in industries, when the machines talk to another machine, okay, so when the machines can transfer the data, or it can communicate from communicate among each other machines using an internet as a medium, right? So then your industrial internet of things comes into picture here. Okay, so what is the advantage of having industrial internet of things? How it is going to help in industry? Okay, so the most important thing is what it is going to increase the productivity. Okay, it is going to increase the productivity. How it is going to increase the productivity? So by checking the conditional parameter. Okay, so by having a conditional monitoring system. Okay, fine. For example, if you have a motor, okay, the motor will have some lifespan. It can and regularly some person has to check, monitor the condition of a motor, whether it is working in a good condition. So if we have a system which can automatically measure the parameters for the motor condition monitoring system, if any parameters goes down, and if you have an option to intimate that the motor is going to will be affected by few parameters. So before the problem occurs, okay, so before the problem occurs, we can just sort out the issue and we can clear, so that we can increase the productivity. Once the productivity increases, automatically the income and the revenue will be automatically get increased. And one more, if you see previously, okay, if you see previously when you see in the manufacturing industries and all, in plants, okay, in manufacturing plants, so when there is a problem occurs, so when there is a problem occurs, so once they monitor the problems, so so what if any issue occurs, right? So the engineers has to move to the respective plant, and then they have to rectify all those issues. Okay, so instead of that, when the respective plant is connected to when they have a smart sensor which is has a capability to transfer the data to internet. Okay, so in the workplace itself, we can just completely monitor the parameters of the machines. Okay, so before the problem occurs, we can solve the issue. And one more, there will be some lot of systems where they have to collect the data. Okay, they have to collect the data in the regular interval, right? So usually what people will do, they'll have some server over there. So when they want to get the data for the analytics purpose, they have to go to the respective server system, and then they have to get all the data, and they can take some action and they can use it for the future purpose. When these systems all are connected to internet itself, right, instead of moving to the respective place itself, so from the workplace, okay, from the workstation itself, so using internet as a medium, so they can monitor all the parameters. Okay, so this is how where internet helps in industry, okay, to increase the profit, okay, and then to which will help us to reduce the downtime, so that the productivity and all those things are going to be increased. Okay, so that's what we say. So they're going to benefit through cost savings due to like predictive maintenance, so improved safety, okay, improved safety, and some other operational efficiencies. Okay, fine. So next one is there are some protocols. So this is what we call as actually industry 4.0. Okay, industry 4.0, we call industrial revolution 4.0. How it has evolved from industry 1.0 to industry 4.0. Fine. So when you see industry 1.0, okay, so industries will have the mechanization, steam powers, and weaving looms and all, where they have some machineries to do some jobs. Okay, when you see industry 2.0, okay, industry 2.0, where the conveyor belts has comes into picture. Okay, so where before industry 1.0, right, so when they want to move the product from one point to another place, where the human has to carry, so in industry 2.0, where the machineries has comes into picture, so which can do some work whatever the human does, right? So all those things can be done with the help of humans. That's what we say. So machines, in the a simple example is conveyor belt, which is used to move the product from one place to another place. Fine. Okay, the next one, if you see industry 3.0, where automation comes into picture. Okay, so what is called automation? So whenever automation is nothing but which is going to reduce the human effort, which is going to reduce the human interaction, okay, to do some task actually, where the computers, electronics, and all those things to comes into picture. So where we can automate a system, okay, instead of a man doing a work. Okay, if you make an automate a system where the machine itself can do the task whatever the human does, So that so those comes under industry 3.0, where so whereas your downtime is reduced, the productivity get automatically increased. Fine. So because and the errors has been reduced because the machines will work much very faster rate than the humans. Okay, simple example, the machines can run for 24/7 year. Okay, so for long more number of years and all. So what we will do, we'll develop some applications, we'll dump into the code, we'll have the systems which can automate and it can work by itself. Okay, so where human interaction is not that much required in automation. The next one is your industry 4.0, which is in the 10, where your cyber physical system comes into picture. That's nothing but your internet of things, when the machines, okay, when communicate among each other and it can transfer the data by using internet as a medium, right? So that's what today we are in industry 4.0 here. Fine. So this is about the industry revolutions and about the industrial internet of things, and we know that we will be using different protocols. So in order to transfer the data, for simple example, if you want to send a mail, so we'll be using SMTP protocol, right? At the same time, if you want to do something to internet, will be using hypertext transfer protocol, that is nothing but your HTTP. Fine. So there are a lot of protocols okay, so are used the transition to the IoT. Okay, so where we have different edge network devices. Okay, the edge network devices, so which uses different protocols for sending and receiving the data here. Okay, so there are a number of different communication protocol. So they'll be using OPC. Okay, so OPC, which is used to transfer the data in your gas and oil and other industries and all. Okay, so we call it OPC client. And then we will be using MQTT protocol, that's nothing but your message queuing telemetry transfer protocol, so which transfers the data, okay, in a quick way, and it's the emerging standard for your industrial internet of things here. Okay, fine. So we'll be using here also, when you see here, to transfer the data, will some places will be using HTTP protocol, and in some places we'll be using MQTT protocols. Fine. Okay, so and one more, so this is about the different protocols which we use in industry, and there are some lot of challenges when IoT comes into picture. The most important thing is security. Okay, so because so when IoT comes into picture, right, so a machine will transfer the data, and through the gateway, the edge devices gateway, the data will be transferred into a virtual cloud. Okay, so where all the data will get aggregated over there. So from cloud, so we have some different platforms where we can get the data, and then we can share the data to the where the people can receive the data from other points. Okay, so here the most important thing is your interoperability and your security are the more are probably the biggest challenges. Okay, so when implementing of IIoT. Okay, so when you see here, the major concern which is surrounding the IIoT, okay, is nothing but your interoperability between your devices and machines that uses different protocols. Okay, and would have a different architectures. Okay, fine. So the companies has to know their data. Okay, whether the data is secured. Fine. Okay, so then your physical system comes into picture. So so that's why still many of the people have started to use Internet of Things, and because of having the security as a reason, so still some people have not implemented IoT based systems in some um, industries. Okay, so in a lot of manufacturing industries. Fine. So this is just a simple introduction about IoT. So next thing is we are going to see how we can push the data. Okay, how we can push the data in a local network, and how we can push the data to the different networks here. Fine. And there is a small video. It's about a Nissan. So I hope in Nissan and Ford and all, they have an automatic car parking system. The car will automatically park by itself by looking into the available spaces over there. Okay, so this and the same thing has been implemented in the company itself to automatically assemble the chair to the respective places. Okay, a simple example, when students comes to the lab or when they comes to any halls, right? So what will say, when they try to leave the hall, try to arrange the chair properly and put it on the respective places when they move out of the lab. Okay, so what they have did is, so they have automated or they have whatever they have implemented in the car parking system, right? The same system they try to implement it in the arranging of chairs. Okay, so this is how this will be just will be shown in the video. you can just have a look at that. So this is a small example for and IoT based applications. There are a lot of applications out there, so where we can build IoT based systems here. Fine. So now we'll get into the IoT part. So here you can just transfer the data with the local network, and you can transfer the data to the from one network to the other network. Fine. So for that we can so you can see here, so there are these are the edge devices. Okay, the edge devices will be connected to the internet. Okay, so devices can transfer the data, so that will be given to the connectivity point. You have LoRaWAN, you can use Wi-Fi, GSM. Okay, so these are the connectivity part, and then it will be connected, this will be transferred to the cloud servers. Okay, and then it can be given to the then from the cloud servers the people can access and they can get the data to the other systems. Okay, so now, so we are going to use a local network plus the gateway. Okay, so I'm going to use here, first thing is I'm going to use Wi-Fi as a medium to transfer the data. Okay, fine. So we'll see how it is going to work. Fine. So when I want to transfer the data in a local network, okay, when I want to transfer the data in a local network, okay, for example, I have two different targets where I need to share the data. Okay, so when those targets has LabVIEW applications, okay, when those targets has LabVIEW applications, right, then I can make use of shared variable. Okay, or else I can make use of network streams to transfer the data from one target to another target or to the different targets. Okay, think that I have some non-LabVIEW targets. Okay, think that I have some non-LabVIEW targets where I have one system which has LabVIEW and other systems which doesn't have a LabVIEW, right? So if I want to transfer a data between a non-LabVIEW targets, so then I can go for TCP/IP protocol, or else I can go for UDP protocol. Fine. So today I'll be showing you about how we can transfer the data between LabVIEW targets by using a shared variable. Okay, so I'm going to show a real-time hardware demo, so where I can transfer the data from my system. Okay, from hardware to my system, right? So how I can access, okay, how I can access and like how I can transfer and I can receive the data by using shared variable, right? So between two different LabVIEW targets. And the next one is going to be, I'll be showing how we can push the data to the cloud. Okay, how we can push the data to the virtual memory. Fine. So that's what the demonstration will be about. Fine. So about sharing a data between LabVIEW targets by using shared variable, I'll be explaining about once I use hardwares. Okay, so next, as of now, we'll see how we can transfer data to the passive storage. Okay, passive storage is nothing but your cloud. So cloud is nothing but your virtual memory, so where we can store the data over there. Fine. So here I'm going to use a Google Cloud and then I'll be showing a demo how we can use IBM Bluemix Cloud to share to transfer the data to the cloud over there. Fine. So we'll see how I'm going to transfer the data. Fine. So here, so we can have a device to device communication, a device to server communication, and then we have server to server communications here. Okay, so these are the different protocols which are used to transfer the data: HTTP, WebSocket, and DDS, MQTT, and AMQP. Okay, so mostly we'll be using MQTT protocol and your HTTP protocol and secured HTTP protocols over there. Fine, right? So now we'll be moving into the IoT part. Fine. So here I'm going to show a demo how I can transfer the data. Okay, how I can transfer the data using a cloud. Okay, the cloud belongs to Google. The name of the cloud is called Firebase Cloud, and the protocol which I'm going to use. Okay, the protocol which I'm going to use here is nothing but your HTTP protocol, the hypertext transfer protocol here. Okay, fine. So in LabVIEW, okay, in LabVIEW, if you see, we have HTTP protocol. Okay, we have HTTP protocol, so which is already available when you install the softwares in your systems over there. Fine. Okay, so I'm going to teach how we can implement an IoT based system by using a Google Firebase Cloud. We are going to learn how we are going to transfer the data from your system to your Firebase Cloud. Okay, so that's what we are going to see right now. Fine. So now I'll move on to LabVIEW part. So from now it will be completely a demonstration by using LabVIEW tool. I hope you people have LabVIEW software with you. Okay, so or you can just take a hands-on later once the session has been completed. Fine. So I'll open LabVIEW file. So I open LabVIEW, and you know how to create a VI file, and then I'm going to select new VI. Okay, so as of now, okay, as of now I'm going to create a project. Okay, I'm going to create a project where I can have all the files, okay, in a single system itself. Okay, so usually what you people will do whenever you want to develop any code, will just create a VI and then you start to develop a logic. Okay, so I'm going to create some applications right now, so that I'm going to use a project where I have, or I can have all the dependency file inside the project itself. Okay, so file, and if you want to create a project, okay, if you want to create a project in LabVIEW, go to files, and then you can select an option called new, and I just click on new over there. Right, so you can see here I'll get another pop-up. Okay, I'll get another pop-up here. I'll just minimize. Yeah, so there is an option called empty project. You can see there is an option called empty project. Just give a click on the empty project, and then you have to give okay. So when I just click okay, fine, automatically it'll create a new project here. Automatically it'll create a new project, and if you see here, so I have project Untitled 1. This is a project name right now. If you see under my project, I have my computer, and then I have some dependencies and build specifications here. Fine. So now I want to create a VI. Okay, I want to create a VI in my system actually, right? Which means that this complete application is going to run in my system itself. Okay, it is going to run in my system itself. I think I got a message here. Okay, so it's for attendance. Yeah, fine. Sorry. Okay, yeah. I'll just go back. Yes. So it's for right click on your my computer, and once you right click on your my computer, you can see you'll get multiple options here. You'll get multiple options here. So new, add. Okay, you can see here. So if you want to add an existing VI, okay, so you think that you have developed a VI, that VI you want to import to the import into a project, you can go for add, and you can select file, and then you can select the respective VIs over there. So right now I'm going to develop a new VI. I'm going to develop the application from scratch. So I'll be going to new, and then I'm going to select VI. Okay, I'm going to select VI here. I'm going to just click new VI, and automatically a VI will be created. Automatically a VI will be created. And if you see, right, so under this my computer, so you can see I have something called as Untitled VI. So once if you want to once you save, you can just give the respective name to the VIs and the project over here, right? So this is how you can create a project, and then you can add the respective VIs. Fine. Next we'll start to develop the code. Okay, It's very simple here. So because I hope you people know, when you create a new UI, you'll get two screen. One is front panel and another one is going to be the block diagram part. Fine. So now front panel, window, you can go for show block diagram. I'm going to expand. Okay, so this is a place where we are going to develop the code. Okay, this is a place where we are going to develop the code here. Fine. So this VI is used to transfer the data from my system to the passive cloud, and the cloud which I'm going to use is a Google based, okay, Google Firebase cloud, and the protocol which they're going to use is your hypertext transfer protocol. That's nothing but your HTTP protocol. Fine. So now when you just right click on the block diagram, okay, when you right click on the block diagram, you can see there is a palette called programming palette where you'll get all the different functions over there. And if you see in your function palette itself, we have an option called connectivity. Okay, sorry, we have an option called data communication. Okay, we have an option called a data communication. In this data communication, you will get different sub palettes. So in this, I'm going to place my cursor on the protocols. Okay, in this, I'm going to place my cursor on the protocol. Okay, and if you see here, I have different protocols here. So you can see TCP, UDP, and serial communications. Okay, right. So is present inside the palette, and you have other protocols also. So I'm going to select HTTP client. Okay, I'm going to select HTTP client because our Google Firebase cloud is going to use HTTP. Okay, so any messages? Okay, fine. Yeah, fine. So I'll be using these functions. Okay, I'll be using these functions to transfer the data from my LabVIEW to your Google Firebase cloud. Okay, so before moving in developing the application, okay, before developing the applications, okay, so right now I'm going to take two things. Okay, I'm going to take two things here. So one will be I'm going to share. Okay, I'm going to share data from my system. Okay, I'm going to share the data from my system to Firebase cloud, and that's nothing but you're pushing your data. Okay, that's nothing but you're pushing your data from your to the cloud. And another one is I'm going to get the information, or I'm going to receive the data from cloud to my LabVIEW application. Okay, so one will be writing the data to the cloud, and another one is going to be reading the data from the cloud. Okay, right. So first one, I'm going to write the data from LabVIEW application to cloud. So for that, I'm going to develop a small logic here. Okay. So when you just right click on the block diagram, anyway, this application is going to run continuously, so that okay, it's going to be a it's going to be application which is going to run continuously. Okay, so then you people know that whenever I want to run any process in a repetitive manner in LabVIEW, okay, I need to use loops. Okay, I need to use loops. So I'm going to use while loop. Okay, there are two different types of loops here. One is for loop and another one is while loop. So if you want to do any process only for the known finite number of times, you can go for loop. Or if you're going to do any process in a repetitive manner for some more amount of time, then you can go for a while loop here. Okay, fine. So let me use while loop. So I'll go to structure palette. In structure palette, I'm going to use while loop. Okay, in structure palette, I'm going to use while loop here. So click, drag, and drop the while loop in the block diagram. Right now, I'll just close the HTTP. Fine. So once we develop, we'll just take the palettes which is required, the functions. So now this is a while loop. Okay, so where I'm going to run the program in a repetitive manner. Fine. And the next one is going to be, so now I hope you people know. So when you want to stop the loop, okay, because loop is going to run continuously. So if I want to stop the loop, I can use a stop button. So right click on your conditional terminal of your while loop. You can just go for create control. Automatically a stop button will be created. Okay, a stop button will be created. And now, and you people are already aware, I hope, whenever you use a while loop, okay, whenever you use a while loop, always we have to use a delay function. The main reason for using a delay function is in order to reduce the more amount of CPU usage. if I lab you, always we have to use a delay function here. So to call a delay function, right click on the block diagram, go to the timing palette, and you can see there is an option called wait ms. Okay, and right click create constant, and let me give 100 millisecond delay, or you can just give a 200 millisecond delay. Okay, so usually according to some constraints, so we'll always use mostly 100 milliseconds so that the application will respond within the given time, within 100 millisecond delay. So right now I have used 200 millisecond delay here. Okay, the function is wait ms, right? So now my while loop is ready to run, and I have an option to stop whenever it is required by just clicking on the stop button here. Next one is, so right now to show a demo, okay, think that we don't have any sensors right now, because okay, real time, because this application is going to be completely running inside a system. Okay, it's not so we have not interfaced any hardware right now. So now in the block diagram, inside the numeric palette, if you see, I have an option called random number. Okay, I have an option called random number, so which is going to generate a number between 0 to 1. Okay, so this random number thing, this is going to be a sensor. Okay, this is going to be a sensor right now. Okay, you can just have an assumption where this random number is going to act like a sensor. This is going to give a data. It is going to randomly generate a number between 0 to 1. Fine. If you want to check that, create an indicator. Okay, and I'll place the indicator here. I'll put it here. Fine. So now I'll run the code. You can see here it is keep on randomly generating a number between 0 to 1. Okay, so now I'm going to push this data. Okay, I'm going to push this data to the cloud. Okay, I'm going to push the data to cloud right now. So we next one is what? So we have some data right now. Okay, so if you use a hardware, then you have to use some hardware APIs in order to get the information from a sensor, and then only you have to use some network protocols to transfer the data. Right now we don't have any sensors and hardware with us. So we'll use this random number. We'll assume that this has a sensor data. Okay, because in your upcoming sessions, the next sessions and all, so some experts from will be handling the sessions related to the hardware. Then you can interrelate. Okay, then you can just combine those things and the Internet of Things together. You can make some IoT based standalone systems. Okay, fine. So now I'll be using HTTP protocol to transfer the data to Google Cloud. Okay, so now right click on the block diagram, and you can go to the connectivity palette, data communication, sorry, protocols, HTTP client. Okay, sorry, so protocols, HTTP client. Yes, right. So now, so after this, okay, after this, so the first function, okay, so the first function which we'll be using is openhandle.vi. Openhandle.vi. If you see here, this openhandle.vi, okay, so which is going to open a client handle. Okay, so this is used to wire your other multiple HTTP client VIs. Okay, so while preserving your, you can see here, authentication credentials. Okay, fine. So where you can specify the username and password if you want to make a secure data transfer if necessary. So to send the web request to the server, okay, for the required authentication. Okay, so it's going to create a reference here. Okay, it's going to create a reference. Fine. So now next, okay, so I think in this there are no required input terminals to give the data because others are optional. The next function will be, I'm going to push the data. Okay, I'm going to send the data from my application to the cloud. Okay, the passive cloud. So I'll be using an option called put.vi. Okay, I'm going to use an option called put.vi, and then I'll be placing in the front block diagram. Okay, and if you see here, this put.vi, okay, if you see, this put.vi has an input called client handle. In and out, it's nothing but a reference, and you can see there is something called as URL. Okay, next one is input is buffer. So this is a place where we have to transfer the place where we'll be sending the data, you have error in and error out. Okay, fine. And next function, which, and now I'm going to connect this open handle here, right? And then this error in error out, which is used to which will help us to enforce the data flow programming. Okay, so now next one, okay, the last one is going, the last function which we'll be using to transfer the data. Okay, to transfer the data is nothing but your close handle. Just click the close handle and then you can place it in the block diagram. Okay, so and this I'm just keeping it outside of the loop. Okay, I'll tell you why I'm keeping the open handle function outside of the loop, or why I'm keeping only the put function inside a while loop, and the last one, why I'm keeping the close handle function inside outside of the while loop here. Okay, so now I'm going to connect this reference in, reference out, and this one. Okay, yeah. So now the reason why I'm keeping the function open handle and the close handle outside of the loop, okay, the reason is when I run the code, okay, when I run the code, only for the initial time I need to create a reference, okay, and the reference has to be sent to the other functions of the VIs, and that's why it has to be done only for one time. That's why I kept outside of the loop. You know, LabVIEW follows data flow programming. The flow of data is going to determine the order of execution here. And if you see, I just kept the put function inside a while loop. The reason why I'm keeping this put function inside a while loop is because this function is going to transfer the data, okay, so to the cloud. Okay, so which is the major part, so where we are going to keep on reading the data in the cloud, right? So that's why, so we have given, okay, so kept the put function inside a loop, because the only thing is what we are going to pushing the data continuously to the cloud until unless we stop the application. So that's why I kept the put function inside the while loop. Okay, if you see the third one, the last one is nothing but your close handle dot vi. The close handle dot vi, once I stop the application, okay, once I stop the application, I need to close my reference, okay, only once the application is stopped. So that's why I kept the close handle function inside outside of the loop. Okay, if I try to keep all these functions, if I try to keep all these functions inside the loop, for each and every iteration, a reference will be created. It'll write the data to the cloud, and then it'll close the reference. And for the next iteration, again, it will create a reference, write, close, which will increase your program memory. Okay. So in order to avoid this, I've just kept open handle and the close handle outside of the loop. Okay, fine. And one thing is what, so still, if you see here, I hope you know, whenever there is a broken arrow in your vi, which means that you have error in a code. So the reason for having a broken arrow in your vi, still we have not given the data. Okay, still now we have not given the data to the put vi function, right? So now if you see here a control h, okay, this buffer, okay, the buffer is buffer input and the URL, both are pink in color. I hope you know there are the different data types in LabVIEW is represented in different colors. Okay, you are pink. You know that the orange belongs to DPL, green belongs to Boolean, and the pink one belongs to string here, which means always it will accept string as an input. Okay, so right now we have, it can accept only string as an input. If you see here, the data which I'm trying to pass, okay, the data which I'm trying to pass is a numeric data. Okay, so when I try to connect this one, okay, the numeric data to the buffer, it will show broken wire, because it will not accept numeric data, it will accept string. And the most important thing is it will accept JSON string. Okay, it will accept JSON string, it will not accept a normal string format data. Okay, so what we need to do, we need to convert the numeric data to the JSON string format data. So in order to convert the numeric data to the JSON string, in your block diagram, right click on the block diagram, there is a palette called string palette. in the string palette, if you see, we have a sub palette called flatten/unflatten string. Okay, so in this I have an option called to JSON. Okay, so which will convert your data to the JSON string. Okay, JSON string. I'll just place here. Okay, so it's to flatten to JSON, and if I just Control H, you can see here it's going to convert whatever the data type you just give to the input terminal of the flattened to JSON string. It will convert into, okay, a JavaScript object notation string. Fine. So now if you see anything, okay, so when I just press Control H, they have mentioned as anything, and the wire is nothing but a cluster wire. Okay, it'll accept cluster. The cluster means group of elements of different data types, and that's why the wire appears in a different appearance. Okay, so we have to, it can accept only cluster data. Okay, so now see, I'm getting a broken wire, so I need to convert this into a cluster. Okay, I need to convert this into a cluster right now. Fine. So in order to convert this into a cluster, okay, in order to convert this into a cluster, I'll go to cluster and class variant. There is a function called bundle function. This bundle function will convert any other data type to the cluster data type. Okay, so cluster is a category which will be supported by LabVIEW. Okay, LabVIEW supports different data types, so like array, strings, numeric, boolean, and cluster. So cluster means group of elements of different data types. Okay, I hope you people know array is group of elements of same data type. Here cluster means group of elements of different data, and now this has been converted into a okay, a JSON string, and now it has been accepted. And one more input still left out is your URL. So right click, create a constant. You can see here. Okay, now my program is ready to push the data to cloud, but only thing is we have not specified the URL. We have not specified the URL still now. So this is the part. Okay, so the sequence which we will be using to push the data from LabVIEW to the Firebase cloud, and the Firebase cloud use supports HTTP protocol. That's why I use these HTTP functions. Okay, so now the code is ready to push the data to cloud. The only thing which is left out here is we need to specify the URL. So the next thing is we will be moving into the Google Cloud to push the data. Okay, Google Cloud to push the data here. So I'll just go to the server now. Fine. I'll just type Firebase. Okay, Google Firebase. Okay, see, you will get this screen. Okay, firebase.google.com. So you can just click on Firebase. Okay, so once you open this Firebase screen, okay, it will ask you to sign in. You can just sign in using your Google account. So it has been already signed in my system. Okay, I already signed in. So okay, right. So now this is a place where we are going to push the data to Firebase cloud. Okay, so there is an option called go to console at the left hand side. Okay, you can just give a click on go to console. Okay, fine. So then it will directly ask you to create a project. Okay, directly ask you to create a project. If you just come back, for example, if you're not going to use go to console, you can see there is an option called get started. Okay, once you select get started also, it will automatically direct you to the window called project screen. Okay, so whichever you want, you can prefer. Both will direct you to the same screen. Remember, open your Firebase cloud, get started, or else you can go for code to console. Okay, and I just created different projects over there before. So now we'll try to create new project. Okay, you can create a new project. You can see here add project. There is an option called add project. Just give a click on add project. Okay, so it will direct you to the next page. Okay, so where it will ask you to enter your project name. Okay, it will ask you to enter your project name. So I'm going to give NCET right now, NCET ECE. Okay, so this is going to be the project name right now. Okay, and you can see there is an option called continue. Okay, just click on the option called continue, and then there is a next step There are 3 steps to create a project. The second step is you have to select your Google Analytics for your Firebase project. You no need to do any change, any settings here. Check whether this is enable Google Analytics for the project. Okay, so and then you have to just give, if it is disabled, make it enable, and then you can just directly give continue. Okay, so once you give continue, it will ask you to configure the Google Analytics. Okay, so you can just select default account for Firebase. You no need to create a new account here. And the last step is you have to just click on create project. And once you click on this option create project, automatically a new project will be created in your Google Firebase. Okay, it will take few seconds. We have to just wait until the project is created. I think almost it is finished to create a project. And next we are going to follow few steps to receive the data from your Labio application to the Google Firebase cloud. Okay, and now you can see your project is ready. Okay, you can just go for continue. Yes, your project is ready right now. Okay, so get started. Okay, and you can see here there are different options available. Next thing is you have to create a database. Okay, next thing is you have to create a database here. So you can see here at the left hand side you have some categories over there like authentication, Firestore, real-time database, storage. You just click on the real-time database. Okay, and once you click on the real-time database, you can see here you'll get different options here. You can go for create real-time database. Okay, if you just create real-time database, okay, first one is database option. It will ask you a location setting is where your real-time database data will be stored. Okay, so no need to change anything here. Let it be as United States. Okay, and you can see here there are two things: start in locked mode, okay, and start in test mode. Okay, so if you make start in locked mode, data will be private by default. Okay, so it will be specified by the security rules. So when you make it as test mode, okay, when you make it as test mode, okay, you can see your data is open, default, enable, quick setup. Fine. So next thing is I'm going for enable. Okay, when you just make enable, right, so it's going to set up a database. Okay, yes, so now your database is created and your project is ready. So the next thing is we have to get the data. We have to get the data from your LabVIEW to this cloud. Okay, fine. Now you can see here NCETECE is your project name. Fine. Hold on a moment. Okay, so now I'll go back. Okay, oh, it's on the Firebase. Yeah, so now if you see the project is ready. So if you see here there is a plus symbol where there is an option called add children. Okay, this is a parent. Okay, the project name is nothing but a parent here, and then we have to add the children. Okay, so in order to add the children here, see there is an option called add child. Just give a click. It'll ask you to enter the child name. Okay, so now we are going to get the random number data. So I'm going to give it as number. Okay, and then value, it is, we know that it is going to accept string as a data. So I'm going to give open double quote and a close double quote. Okay, fine. So then there's an option to select add. When you just click on add here, you can see here This is a parent where your child is added. It is number. Okay, it's number where we can get the data from LabVIEW to your Google Firebase Cloud. Next one, I'm going to create one more child. Okay, I'm going to create one more child. So where I'm going to push the data. Okay, I'm going to get the data from my cloud to LabVIEW. Okay, from my cloud to LabVIEW over there. So I'm going to place my cursor again on the parent. Okay, NCT is your project name, and there is an option to add a child here. I'm going to just give click. Okay, I'm going to give a name as data. Okay, data, open code and double code. Okay, close and then give add. You can see here data is added and the number is added. Okay, fine. So initially we are going to push the data from LabVIEW to cloud here. So just click on the number. Okay, because this is a place where you're going to get the random number data here, and you can see here there is an URL. Okay, http colon double slash the project name. Okay, so you have to copy this. Okay, so copy the URL, and now we'll be moving into LabVIEW. Okay, and then in this place, this is a place where you have to paste your URL. So Control V. Okay, the URL is placed, and the most important thing is your extension should be .json. Even though if you copy the URL and if you run the program, you'll not get the data. Only if you just copy the URL and if you put extension as .json, then only whatever the random number which is generated in LabVIEW application, that will be pushed into the cloud over there. Okay, so now it's ready. Let me run the code. Okay, the program starts to run now, and if you check and if you click the child class, you can see here it is generating a number from 0 to 1. Okay, that's the indicator name over there, and you can see here whatever the data. And if you have doubt, I'll make the front panel here, and you can look into the cloud. Okay, see whatever the data we are just generating over there, the same data will be pushed to the cloud, and we are receiving the data here. Okay, so even if I just copy the URL, it is now public. Okay, if I just copy the URL, right, and if I share it, you can develop a logic and we can push the data. Fine, you can see here. So this is how you can push the data from LabVIEW, and then you can just get the data to the cloud here. Fine. Okay, yes. Next step, I'll stop here. I'll stop the code. Okay, once I stop the code, see the code has come out of execution, and immediately if you see, this is the last number which is generated by the random number variable. The same data is available in the cloud, and automatically, okay, here also the updation has been stopped. And again, if I run the code here, you can see immediately it will start to update here itself. Okay, so this is how you can make use of HTTP Google Firebase Cloud to transfer the data from your LabVIEW to the cloud passive cloud here. Okay, like this you can make use of AWS, Amazon, AWS is there, Microsoft Azure is there. Okay, and then you can make use of IBM Bluemix. There are, and ThinkWorks. There are different clouds are available. So for each and every cloud, other clouds and all, you have to download the toolkits. Using those functions, you can push the data to the respective clouds over there. Okay, so the next step we are going to see how I can get or how I can receive the data from your Google Firebase to your cloud over there. Okay, to your LabVIEW application. So now so this will be your parent class. Okay, and this is the place where we are going to transfer the data. Fine. Now I'll come back to LabVIEW programming. I'll go to the project. Okay, I'm going to create one more VI. Right click on your My Computer, new. Okay, and then VI, right? Yes. So same steps. I'm going to use a loop to transfer the data, and then a delay function. 100, let it be a 200 millisecond delay, and then HTTP. Here I'm going to control an on and off status of an LED. Okay, so for that I'm going to take a Boolean indicator. Okay, this LED will be turned on and turned off by getting the command from your Google Firebase cloud. Okay, so I'll go to the connect data communication protocols, HTTP client, open handle. Okay, and the next one, now we are going to get the data, so get.vi. Last one is going to be the close handle. Okay, close handle. So I'll be connecting the reference initially. Okay, and the next one, yes, and now here it's connected. The error narrow to enforce the data flow programming. Done. And then we have to give the URL here, create constant, and here we'll be getting the URL. Okay, fine. And here you can see header and the body. So under the body only we'll be getting the information from your cloud. Okay, your code is ready now. Only thing is you have to copy the URL and then you have to put it here to get the information whatever we provide in your cloud to this LabVIEW application. Okay, so I'll go back to the cloud, and then this is the child name. Okay, yes, I'll copy the URL, I'll put it here. The most important thing is you have to put an extension .json. So this is very, very important, or else we'll not get the data. Okay, yes, it is done. And now if you see, I'm going to run the code. Okay, see, I'm not get any data here, so I'm going to click here it as on. I'm going to give enter. Okay, and if you see in the LabVIEW application, you have received the command call on here. Okay, so based upon this on and off command, I'm going to turn on and turn off the LED. Okay, so to develop the logic here, let me just use, I have to take only the command on from the information. So I'll go I'll go for string. There is an option called string subset. Okay, I'll use this input here. Fine, and the offset will start from, I'll make the offset 1. Okay, so always offset starts from 0. I'm going to make it as 1, and I'm going to create the length as 2. Okay, when I make the length as 2 here, so this is a function called string subset function. So whenever you want to extract a particular portion of a string, you can make use of the function called a string subset function. Okay, so if you want to check the output of the string subset, so I'll get the information as only on. Okay, if you want to check here, see, I have double quote on and close double quote. Now I'm getting only on here. Okay, so this I'm going to compare to turn on and turn off the LED. So I need to develop a logic here, equal, there is a function called comparison, equal to on. So this comparison function is going to give true. Okay, and I'll give it to the Boolean. so that the LED will get automatically turned on if it is on. Okay, and now if you want to check, I'm going to give a command as off now. I'll make this VI here. I'll place it here so that you can see the command. And this portion, I'm going to give off. Okay, enter. And this is a VI where the LED will get automatically turned off. Okay, fine. So this is a parent class. Okay, so where you have two childs, and if I run both the code, okay, I'm going to run the random number also. Okay, you can see here, see the number is keep on generating, and here for write also, if I just give an on command, enter. Okay, so this will get
Sir, you have last 10 more minutes.
yes, ma'am. Yeah,
You
yes.
can.
I'll try to yeah, I'm
Yeah,
going to
sure.
conclude now. Sure.
Okay.
So yes, you can see here. So I'm going to transfer the data from LabVIEW to cloud. At the same time, I'm going to receive the data from cloud to LabVIEW. Okay, so this is how you can make use of a Google Firebase Cloud, and you can use LabVIEW and platform to develop an IoT based system. So I hope you people know it's a completely a graphical based programming language where you need to follow any syntax to develop any application. So if you have an hardware with you people, you can make use of by creating a standalone system, okay, IoT based system by using your lab and the respective NI hardware. Fine. So if I just stop the code here, so I can stop so that see automatically it stopped the so Firebase also it stops to read and write the data from and to the cloud. Okay, so this is how you can create a small IoT based system in LabVIEW. So you can make use of AWS. We have some separate toolkits over there. If you see Windows, this you have to separately download. This HTTP will be available when you install the LabVIEW software. If you see, there is an option called add-ons where if I use download a tool called IoT S Portal platform from VI Package Manager. Using this, I can make use of IBM Bluemix Cloud where I can read and write the data. Okay. At the same time, if you see, I have AWS where I can make use of these functions. Okay, to get the data from your AWS cloud. Okay, fine. So this is how you can make use of different cloud platforms, new VI. So for example, if I just go to this one, add-ons, S Portal, IoT Foundation, there is an option called example. Okay, example quick start. I'll place it here. Automatically, it will direct me to the another page. Okay, so this program will automatically start to run where it has some IoT based functions here, which is used to transfer the data from your LabVIEW to IBM Bluemix. Okay, I'll try to check whether I can log in now. IBM platform. So just only thing is if I enter my IP address, let me check whether I can get the data. So I need to sign in here. I'll check once whether I can do now. Yes, I think it is signed in. Just I'll show a small thing. I have something called launch quick start. Yeah. So this is a place where you can see that code consists of a random number function. I hope you people know which will directly fine. I need to enter my device ID here. So my device ID is nothing but my IP address 192.168.43.119. 192.168.43.119. I'll go with go. I have to run the code here. 192.168. It's 43.119. I'll run here. Yeah, connection is active. So I'll go here, and you can see here whatever the data which is generated in your LabVIEW platform, that is displayed in your IBM Bluemix cloud. Okay, so this is a simple example. So where you can even how we have developed a logic for to push the data from LabVIEW to your Google Firebase Cloud. In the same way, we can make use of this IBM Bluemix also to read the data, to transfer the data from your application to IBM Bluemix. So for that, actually, you need to follow a lot of steps to first create an account. So, and it is completely secured. Okay, it's not like Google Firebase. You have to create an account, and then you have to create some organization ID. Then only it can make it to develop an application. Then when you push a data, you can receive it in IBM cloud. Hardly takes more amount of time. The same thing is applicable for Amazon cloud also. So that's why for the given short duration span, I just took Google Firebase cloud to explain, and I tried to demonstrate a small application where you can create some applications to transfer and receive the data using Firebase. Okay, in the same way, you can make use of IBM, ThinkSpace, and even AWS also to publish the data using your cloud. Okay, fine. So you can see here, see what are the data I'm publishing here. The same thing is displayed in your IBM Bluemix also. Fine. So with this, I'll conclude my session. So if you have any queries regarding NI technology, IoT, or any support regarding NI, LabVIEW as well as hardware platform, you can reach me through my email ID. And this is my contact number. You can text me if you have any queries also using this. I'm looking for a magnifier right now. Just a second. Yeah, so this is my contact number and my contact number and my email ID. So if you have any queries, let me know. So we'll support you regarding NI technology. Fine. So even I can just drop my email ID and the contact number in your chat. So if you people can note down. So thanks for giving the opportunity. I hope it will be a useful session for your people to understand how IoT works and how we can create a application using NI technology. So if you have any queries, feel free to ask. So with this, I'll conclude my session. So now it's your time. You can just.
Thank you, sir.
Thank you, ma'am.
Thank you for the coordination throughout the program for the
Yes,
session 1 of day
Yes,
3. Well, participants, I request you to join for the next session by 11:30. Okay. Well, thank you, sir.
Yes, thank you so much. Ma'am, can I leave the meeting? If you people have any query, you
Yeah,
can
any
just ask.
queries is there, participants, you can ask us.
So I hope your next sessions will be on hardware-based platforms, so where the experts will show and they'll demonstrate how you can make use of NI hardware for your research purpose, academic, as well as to develop some applications. So along with this, if you merge this IoT technology, you can build some real-time IoT-based systems. So if you have any queries, let me know.
Okay, sir. Well, thank you, sir.
Okay, ma'am. Thank you so much.
Thank you for the session.
Thanks for giving
Thank
the
you.
opportunity. Thank you.
Thank you. Thank you.
Thank you.